So adding vectors. Adding vectors. So the first one we're going to talk about, a couple different situations. The first one is that if we have two vectors going in the same direction. Same direction. So I'll give some definitions to this, but first let's do an example to see if we can make sense of it. So let's say we want to find the sum of two vectors. Find the sum of two vectors with magnitudes 3 and 4, both in the direction of 40 degrees. Direction of 40 degrees. So if I have, this should be in quadrant 1 since it's 40 degrees. So let's say the first one looks like this. So right here is 40 degrees, and this one has a magnitude of 3. Now the next one, this is also 40 degrees. So if I'm going to start from the end of the first one. If I had a 0 kind of over to the side like this, then from there, 40 degrees would look like that. So this is 4. So they're both 40 degrees. They're going in the same direction. That means that this new one made, this full thing, this has a magnitude of 4 plus 3 is 7. Just add the 3, add the 4, and then the direction would be still 40 degrees. It's still going in the same direction, it's just combined. So when I'm adding vectors and they have the same direction, I'll go back up to add a definition. We add the magnitudes and keep the direction, or just we'll say same direction. And it's the same direction. Okay, so now how about, let's do an example where the two vectors are going in opposite directions. Again, we'll go back to the definition in a minute. You might want to leave a little bit of an extra line this time. So this example, let's say we want to find the sum of a vector with magnitude 8 in direction of 30 in direction 30 degrees, and another magnitude 5 in direction 210 degrees. So if I sketch this out to see what this looks like. So the magnitude of 8, direction of 30 is going to be something like, maybe like this. 30 degrees, magnitude of 8. The second one is magnitude of 5, direction of 210. So 210, here's 180, maybe something like this. All the way around, this is 210. And this one has a magnitude of 5. So these, if we look at it, it looks like they make a straight line. They're going in exactly opposite directions. Now if I instead took this magnitude of 5 vector, if I took this and I moved it to end at the start at the endpoint of 8, really it would kind of look like this, where I'm going backwards on the blue line, on the first line. So what I'm left with though, that leftover blue part, I still have right here, this is still going to be going in a direction of 30 because it's like the magnitude 8 is stronger than the magnitude 5. If I read, let me kind of redraw it down below. So here's my magnitude 8 at 30 degrees. Here's my magnitude 5 at 210 degrees. So if they're pushing against each other, the 8's going to win. So what we end up with, this leftover right here, going, okay, so this is going to be a magnitude of 3, because it's, if you look at the difference of those, they're working completely exactly against each other. That blue, that little line I just drew is a magnitude of 3, and the direction is going to be 30 degrees. So whenever we're going exactly the opposite direction, so the directions have 180 degree difference, if they're going directly opposite directions, we subtract the magnitudes. Subtract the magnitudes. And then the direction is the direction of the stronger, of the larger magnitude vector. So whichever was the larger magnitude or the stronger one, that will be the direction of the answer. Okay. Now this one, the next one, one more basic one so we get to something a little more steps to it. Scalar multiplication is, we're talking about something like this. So again, I'll leave some space for definition, but let's say we wanted to find the magnitude and the direction. Find magnitude and direction of 3 vectors with magnitude 4 and direction 70 degrees. Okay, so let's draw this one out. So magnitude 4, direction of 70. So maybe pretty steep in quadrant 1. So if right here, this is a magnitude of 4. Now if I have 3 of the same vector and I line them up, there's 3 of them. Okay, it's kind of like the addition one, where the magnitude is just going to be them added. 4 plus 4 plus 4 is 12, or 4 times 3. And then the direction is still 70 degrees because they're all going in the same direction. So with scalar multiplication, we multiply the magnitude and then we keep the same direction, whatever is in the problem.